AMC 10B 2015 Problem 10. What is the sign in units digit of the product of all the odd negative integers strictly greater than negative 2015? So if a negative number is greater than another negative number, that number, the absolute value of it has to be less. So negative 2015 is less than negative 2013, is less than negative 2011, yada yada yada, which is like negative 3, then it's negative 2, so number line, so that should be able to quickly solve and understand what it means for a odd integer to be greater. So what is the sign in units digit of the product of all the odd negative integers strictly greater than negative 215? So we have a sequence going, so we have negative 215, we have negative 213, we have negative 2011, this goes yada 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 all the way down to negative 3, negative 1. And these are all the integers that are strictly greater than 2015, so we cannot include 2015, we only include this series. So every single time we increment by 2. So arithmetic series, we can draw a general solution. A's of n is equal to a's of 1 plus n minus 1 times d, n being the number of numbers, n being the nth position of the given value. So a's of n, that's the general term in the sequence, will be equal to a's of 1, which is negative 2013, the first term, plus n minus 1, so n minus 1, whatever that quantity is, times d, which is the increment, which is 2. So this becomes 2n minus 2, which becomes negative 2015, plus 2n, where n starts from 1. So then given this information, we need to know when it equal to negative 1. So when this is equal to negative 1, that means, or actually no, we're trying to find the sign in units digit of the product of all the odd numbers. Okay, so all the odd numbers, we need to find n. So 2n minus 2, so that's equal to negative 1. So 2n is equal to negative 1 plus 2015 gives 2014. N is equal to 1007. So there are a total of 1007 terms because n goes from 1 to 1007. So that means 1007 terms. Well, we just need to understand what it means for an odd number of odd numbers to multiply by together. So for instance, just do a simpler case. If I have negative 1 times negative 3, that's equal to a positive number because I have two odd quantities. But since I have an odd number of quantities over here, that means that the quantity after multiplication should be negative. So we can eliminate all the positives. So this is wrong, B is wrong, then D is wrong. And then we try to find the units digit. So units digit, well, that's just, there should be a pattern in most cases. So let's just try to solve it. So I'm going to clear up some space. There we go. And we can do it from here. So it will be 3 times 1, which becomes 3. And then it becomes, so it's 3, 1, and then it's 0, 9, 7, 5, 5, 3, and then this pattern goes on and on and on. So 3 times 1 is 3. Times 9 gives the units of 7. 7 times 7 gives 9. 9 times 5 gives 5. 5 times 3 gives another 5. 5 times 5 is 5. Oh wait, 5, and then we have 3 again, which is here. And then 5 times 3, and then 5. 5 times 1, and then 5. So we see that the units digit will forever be 5. So that means it has to be choice C as our final answer.